Okay. Okay, so welcome back everyone to another game dev stream recording. So last time we got the rendering for our bitmaps working. So in particular, we've developed a .qi custom decoder, very short, all in Z. We use that to get a bitmap, and now we're rendering the tiles of this game on screen. Today, currently, however, these levels or these tiles that are being iterated through are just temporary ones. It's this data here. And so, this morning, what I want to do is write a parser that will enable us to write these levels in some simple format in a text file, and then during compilation, just move that into this kind of stuff. And then if we just have a single file that's a text file that's easy to edit, it will be really easy to change these levels, to change their order. We won't have to just worry about all of this formatting. I feel like, in general, for like a simple game like this, it's nice to have some separate file for all of the levels, and then they can be edited separately, compiled, stuff works. Okay, so in particular then, the stuff that we want to do today is kind of this one here. And hopefully it will just take this morning, but possibly it might take longer, we'll see. Okay. So where to begin? Let's just create like a new level called levels, a new file called levels.txt. And I think it would be good to have some comments in this. So we can just say the file where the handcrafted levels for the 4x4, or rather for the game get loaded from during compilation. Let's actually just copy these in now, and let's just kind of simplify a lot of this stuff. Get rid of all of these. Okay, let's just get rid of all of these, and then okay. So I'm thinking the file will simply look like this. It would just be kind of numbers. It would be good in here to actually sort of indicate what these refer to. So for the tile type, we did, where is it? It was an I8. Up here. We did annotate what this is. It would be good to copy this over into the file as well. Slightly weird that as a text file, Emacs is syntax highlighting that line but not that line. But anyway. So why don't we just call this the key? And we can 0 denotes an empty file, and then or rather, yeah, empty tile. 1, 2, 3, 4. Fixed tiles, and then get -1, -2, -3, -4. Saying selected tile is a bit vague. What I really want to say is tiles that we're allowed to move around. So perhaps movable tiles is better. Movable tiles. Okay. Okay, and then I actually think that, okay, I just added in these like movable tiles. I think starting out any of these games, there's not going to be any movable tiles already on the grid. All of the movable tiles will just be one selected from the bottom here. So actually I can probably just replace this line, but instead note that all movable tiles, down a bit, all movable tiles in the game will kind of be yeah, are moved onto the grid. So do not need to be accounted for in this. Okay. Well, in these levels. Okay. And I think it would be good to have at least some indication, some way to index these puzzles, even if perhaps in the actual game we don't really mention them. I think it still could be useful for our purposes. So maybe we actually just leave these as comments. Like we could say this one is level 1 and this one is level 2. Note that like these are not by any stage like will these actually be like the fixed final levels of the game. I just want to build the infrastructure in place so that when we do get to the game design part, we can just do this easily and it not be tedious. Okay. So I'm gonna move this slightly around. Okay. So then let's write this parser. So it should be fairly simple. Like we just, what are we gonna do? We're gonna like go through this file, and then as soon as we come to a line which has a character that is that's 0, 1, 2, 3, or 4, we go, this is like a level, so the next 4 lines should also be like all of these characters, and the first 4 characters in each following line should just be numbers, and then kind of import those, and then kind of store that as a different level, and then like move up. Okay, so maybe actually, yeah, why don't we, since we're doing this, since we're only going to be calling this function once, it would actually be easy to store this in a different file. So why don't we call this kind of level parser .zig. Okay, and then we'll start a new file. So we want the standard library as usual. And then here, yeah, we want to define this function. Just called what? Like export. Or maybe just like process pass levels. And we don't really need this to take in any argument at all, but we do want this to output something like this, something of some fixed array of type tile. I think it would be useful to have a, I'm thinking it would be useful to have perhaps just a fixed value telling us what the number of levels is, but maybe we can instead do this with comp time in some way. Given that many of the levels we create would just be like test levels that we might want to get rid of, I think it does make sense to just have like a concrete number of levels. We can say number of levels let's just call it 2 at this point. So then this will just return number of levels and then a grid. Okay. Okay, we should also have our level file name, which in this case we just want to be called levels.txt. And I now have like a Z question that I'm not sure what we'll do. If we import this file from when we import this level parser from Zig, if I declare like grid to be a certain type here, and I also declare grid to be a certain type here, am I gonna get blasted from the Zig compiler by like declaring something in 2 places at once? I am not sure. It's hopefully not. We'll continue with this as a separate file, and then we'll deal with this when it comes to compilation. Okay. So, and yeah, so currently let's just say level data is equal to level string data is just equal to what happens when we embed this level file name. Okay. So now we've got that. We want to start parsing this. Okay, so what's the best way of doing this? We could tokenize this over the lines, but it's been a while, so let's look up some reference of how to do this. I think like the very first example on ziglang.org actually has an example of how to do this kind of tokenizing. I'm being silly. There's no need to tokenize this if we're actually embedding this as a file. Like we can do this in a really simple way, which is just to read the bytes in this thing here. Okay. So why don't we just say for the bytes in level string data, we can just even have a switch statement, I think. Right, perhaps not a for loop, but rather a while loop. So yeah, why don't we let's take the size of what this file will be. So we can just say number of bytes is equal to the level string data dot length, and then let's create a variable that is just going to index where we are in this. So we can say byte index is equal to 0. And we also want this to be of type usize. Okay, so now we can say while the byte I is less than the number of bytes, let's kind of switch on what this. Let's switch on what the what this level string data and the byte I is. So in particular, if the byte is this kind of comment, we're just going to basically ignore this. And then we're going to increase the byte index by 1. Otherwise, let's say it's a new line. Again, we can ignore this, not do anything. Actually, instead of dealing with all of these things separately, I reckon we can actually just move all of these cases into an else case, and like the else case is just to go to the next byte. And then only when we actually run into the very first number do we do something. But this would cause an issue with this stuff up here. So maybe it's then when the previous byte is a new line, but then we move on to a character, then we start saying we've got like a new level. Let's do stuff in it. Okay, this approach of just doing things on a byte-wise level, while it could be simple, it actually seems to be a bit more complicated than simply breaking this up into a list of lines and then just going through every individual line. Okay, yeah, I'm kind of tempted to do this instead, actually. Okay, yeah, we'll do this. Okay, so let's then, yeah, let's clear this out. So we will actually do this tokenized stuff. Okay. So how does this test work? Have some fixed array of integers, and then we're saying, kind of tokenize this, where we input the stuff here. And then this is like the while loop syntax, where it doesn't actually have to be like a boolean, but if it's like a not null, it goes to the next. We looked at this many streams ago. Okay, so let's use this as a reference. Okay, so we want to say, do you need to set up some allocators? We might actually be able to go backwards in time on the Butterfly app, where before we had the comp time parser, we did have a parser that dealt with this kind of, that did this kind of thing. Yeah, this could be useful. Let's do this then. Okay. So we'll go back to this butterfly quiz and then do git log one line. And then we just want to move down to the part where before we did the comp time stuff. So where exactly was this? Got comp time parser working. Okay, so probably this is the part that we want to go to. So let's do git check out blah. Okay, and then let's check out, well, what did the project even look like here then? We did have something called parser.z. Okay, so what did we do? So we defined an arena, this heap allocator that we initted with a heap page allocator. Got an arena allocator out of this, and then where did we use this? I see, we created an array list using this arena allocator and then started doing stuff with that. Okay. why don't we just, Okay, let's actually copy this completely, and then I want to check out the documentation again. Okay, so yeah, butterfly quiz parser.zig. Yeah, we'll literally just copy this over and then modify it as necessary. Okay. By which I mean delete most of it. So yeah, got this, got this. So in this case here, I guess we want to call this like level lines. And or do we actually want this? No, because we're not passing this into some complicated pre-built struct. Like we're already kind of since we're doing this statically anyway. We don't really need this. Okay. But in any case, create some dynamic list. This is kind of what we want though. We want this one instead. We want to just initialize an array list with of strings. And then yeah, we're tokenizing over this because of Windows. And then over each line we'll still use this to begin with. Field list, no, we don't really need to do that part anymore. Field iterator, no, we kind of don't need this any as well either. Yeah, for the rest of this stuff, don't really need it. We certainly don't need this stuff. And okay, this is the simple scaffolding that we need. Okay, let's clear out that parser then, and instead load it with levels, and then let's reset this change we made in the butterfly quiz. Undo this operation with git switch dash git switch dash. Okay. And hopefully this is back to usual. Yep. Okay. Okay, so back to the parser, which I want on the right side of the screen. Okay. So we've got this, and yeah, now we just need to pass these. So now I can really say at the start of every line, if the character is not 1, 0, 1, 2, 3, or 4, ignore it. Just move to the next line. So why don't we say, while we're going to the next line, if the first character of the line doesn't equal a 0, or we can actually do this with the switch statement. Let's instead of having like I think this switch statement would be longer, so I think it's actually okay just to say the first character is equal to this, and then we can say if, let's call it FC for first character. If this FC is equal to the character 0, or rather if it's not equal to this first character for 0, and it's not equal to 1, and it's not equal to 2, and not equal to 3, and not equal to 4, then we're just going to continue. But otherwise, we've actually got a line. And then we can just start processing it. Yeah, so why don't we say now then, let's keep track of how far we are through any one of these grids. So why don't we say, not a constant, variable chord grid row number, and we'll start off at 0. Okay. Okay, so we've gone through this, and now when we reach in execution, we have found one of these lines. So then we need to just see if the grid row number is 0, and then if so, we're going to start creating a new level. But actually, maybe we can just keep the level as itself a static variable that we're just going to continue to fill, and then once we've filled it, we'll then save it. Okay, so we can just say current level is equal to, well, is something that has type of tile, but is otherwise at this point, yeah, undefined. Okay, and then, so now we want to just start kind of filling this up. We can just say, if we've reached this line, look at the current row number and then just fill in the characters. Fill in fill in the current level, or rather like create the current level data. So now we can actually have a switch statement, and we want to switch over well, we want to say for the first 4 characters in this line, let's switch on these characters. And if we have a 0, why don't we this is no, yeah, we actually only need 1 index in this case, which is this. So we've got this index, and now we're switching on that position in the line. If we end up with the character 0, simply fill in a 0 into the grid. But I don't think there's any need to do this when we can actually just do this with ASCII instead. We can just do ASCII conversions. So instead, why don't we just say current level at the current grid row number, and the index here is just going to be the line I minus the ASCII number for 0. Okay, it would be good just to validate this a bit. So why don't we say then instead that the character is equal to this, and then we want to make sure the character is either 0, 1, 2, 3, or 4 exactly before we actually save it. So so we can just say, instead of character here, we can just even say tile is equal to this minus 0, And now we want to check that the tile is in 0 to is 1 of 0, 1, 2, 3, or 4. So particularly we can just say standard.debug.assert that 0 is less than or equal to tile, and tile is less than or equal to 4. And then assuming this passes, now we can just say all of this stuff here is equal to the tile. Okay, when we get to the end of this loop, we could possibly be at the very final character in any of these levels. And if that's the case, we want to reset the grid row number. Also, the grid row number is something we should be kind of increasing or setting to 0 here. So why don't we just say then the grid row number is equal to the grid row number plus 1 divided by quotiented out by 4. Just take this mod 4. And then this should, yeah, this should just go on and on and on. While we haven't yet tested this, let's just print out at this stage what the current level is. So I'm going to debug current level, and then just print out any's fine. Print out this current level, and then we now want to actually write it to this thing that we're returning. Okay, so here I guess we should say variable level data is going to have a type of this number of levels, and it's a grid, but is currently undefined. And then we want to just assign this. We should also have a counter which is keeping track of the current level index. Let's make this 0. So then at this stage we want to say level data current level index. This thing is going to equal the current level. And then we then want to increase the current level index by 1. And then we need to be careful. We only want to actually be assigning this stuff when the grid row number has just been reset. So how should we do this? Maybe actually we move this part out of, we move the the equals 4 part out of the loop. Okay, so we're still going to increase the number. Wait, what just happened? Why did my Windows, why do you just turn on HDR settings when I press some buttons? Go away. Okay. We only want to do this if the grid row number is actually equal to 4. So if the grid row number is equal to 4, now we're going to save it, and then we'll reset the, not only are we going to increase the level index by 1, but we really want to reset the grid row number. So yeah, reader number is equal to 0. Save this current level, move up the level index. Okay, and then what should we do? We should also have an assert that says once we've gone through all of these lines, the current level index should equal the number of levels we actually had. So let's put this in. After all of the lines have been parsed, or like let's say having gone through, check that the number of levels, I guess process, I was going to say saved, maybe process is a better word. Processed actually equals the number of levels. So now we can say debug standard.debug.assert current level index is equal to number of levels. Okay, I'm doing a lot of these like debug.assert, so I kind of just want to make an abbreviation for this. Dassert is now going to equal standard.debug.assert. And now let's do replace all instances of standard.debug.assert with dassert. Except that first one. So yeah, replace. Okay. And I think we should just immediately test this now. So yeah. So let's do yeah, zig run level parser.zig. Okay. Why is this? Have I done something really silly with this import? Oh, it's meant to be a constant. Oops. Okay. I guess I should say constant dassert as well. Okay. 7 expected. Why do I keep forgetting to put constants in front of all of these? Easily fixed. Okay, line 30. Unexpected expression found. This after the end, yeah, because we want to check that the first character is not that. 37 needs semicolon. 49 expected comma after argument. Oh yeah, this is meant to be a double equal sign. And then 5 undeclared use of identifier tile. Right, this is because tiles are signed 8-bit integers. 28 use of undeclared identifier test input. Yeah, because we're tokenizing the level string data. And now what? 40. Use of undeclared identifier dprint. Yes, that's because dprint is debug print. 52 photo info array. Yeah, we're definitely not doing that anymore. So why don't at this stage we just print out what the level data is. So we could just say levels, and here we want to print out We should actually have a main function just for this, by the way. Like we won't just to do this. So parse levels. Okay, main void. So we just want to say level data is equal to parse levels, and then we want to move this to here. And yeah, we just want level data. Okay. Once again, forgetting const. This one looks more serious. Variable comp time int must be const or comp time. Right, we should specify what this is. So this is something of view size. Likewise, the current level index. Um, 38. I8 does not support indexing. What? Since I should be a type, or what is it? So it's not liking the grid row number. But grid node number is of type usize. What's happening? Okay, let me think about this data for a bit. Maybe by analyzing it, this I8 will reveal itself. So the only thing of type I8 is this tile, and so apparently we're like using a tile for an index somewhere in here. So where? Okay, so this current level is just something. It should be something of type tile. Yeah. And then we're saying look at the grid row number. Oh, maybe. Okay, I see. I was assuming that this was a 4x4 matrix instead of a single array, and so I'm kind of trying to do a double index here. This is easily remedied. So to convert this like matrix, this 2x2, this 4x4 matrix to this 16 array, we just want to say multiply the grid row number by 4 and add on the I. What? Why does this still not like this type? Isn't everything here a usize? Iterating over the I here, the grid row number is this. I8 does not support indexing. Oh, because instead of a tile, it should be a grid. Okay. Oops. That was pretty silly. Okay. Again, wait, what? Expected type I8 found U8. Oh, okay, we need to convert this. So we just want to do, this should be of type I8, and we want to do a int cast. And then, what's this? Function with non-void type implicitly returns. And this is good. Like this is what we want. Our current level, we do have two levels. Implicitly returns this. Oh, but we forgot to actually return this at the end. Okay. So now we just want to return the levels, right? What's it called? The level data. Okay. This is compiled, and I'm seeing some levels, even if it is failing. But we will fix this. So, I'm seeing a lot of I'm not seeing not many numbers that are 0, 1, 2, 3, or 4. I'm seeing lots of negative 86s for some reason. But this is okay. We will figure this out. So what's failing? Out of bounds, index 2, length 2, during this, line 45. Why would this be failing? So I think there's two issues. The one is trying to figure this one out. The two is just checking if this debug information that's printing is what we would expect, since the two may be related. I kind of just want to check this first, since this 86 is weird, and then we'll see if it's correlated. Okay. So let's also just like print out a bit of what the actual level data looks like. Since we want to know that. Okay, so all of these lines here are corresponding to this line. And so we're saying just literally print out the current level, which should just be this array of 16 integers. And we're running this each time we go to the next line. So each time you go to the next line that hasn't already been continued because a non-interesting character has been found. So, alright, so the very first time we print the debug statement, we just expect to see like 1, 0, 3, 4, and then everything else should be some random data. But we're not seeing those aligned in that way. We're seeing like 0, 1, 3, and 4 here, and then these are getting overridden. So something's definitely off with the indexing. Let's fix that. So in particular, the part where we're assigning stuff to the current level is incorrect. What? Why is... I'm not immediately seeing it. Like if I is changing from 0, if I is either 0, 1, 2, or 3, then we're increasing this index by 0, 1, 2, or 3, but we're not seeing that reflected in these first 4 values. They're instead getting spread out in some weird way. Like, why? I see. It's because we're increasing this grid row number each time in the loop, when we should only be doing this actually after the loop. Okay. Yeah, let's actually move this below this debug. Okay. Yep. Okay, much better. This is what I want to see and what I expected to see. Yeah. Very first time it encounters the line, we get those values. Everything else is kind of random. Then we get the next ones. Then we get the next ones, and then we finally get it. And then it runs a bunch of times again when it refills up this current file, this current data with the new stuff. And yeah, let's check. It should be, everything's kind of 0 except for like 4, 1, and 2. And yeah, all of these are 0, the 4, the 1, and then the 2. Okay, this looks like it's working. Okay, let's save this then. So we just want to add in the levels.txt at this point and the level parser. You can say got basic, and that's all it needs to be. Got basic level parser working. Probably. It seems to be fine. Okay. Yeah, so then with let's now import this into the main game program, and yeah, and then once we've done that, it will be dynamic, and then from this point on, if we want to adjust the levels, all we need to do is adjust this file. Okay, so let's get rid of some of these debug statements then. And actually, in particular, we can get rid of this entire main void. We're not going to be calling it in here. Yeah, so now let's go back to the main. And we want to import this now. So now we want to import const parser is equal to import level parser.zoo. Let's just make this kind of neat. And then, yeah, let's get rid of this stuff here. And instead, we just want to say, I was too quick to get rid of that almost. This stuff here, this handcrafted levels, this is where we now want to replace this with the constant stuff. So now we want to say, I feel like this stuff should actually be moved upwards a bit. I feel that, okay, this line in particular should get moved up. Both of them should. Okay. The other ones can stay. Okay. So now we can get rid of this to do finally and say these handcrafted levels are now going to equal the result of calling this level. So now we want to say parser.parse levels, and yeah, the result of that should be our levels, and then we can say the number of these levels is then equal to the length of these things, so we can get rid of these. It may still be good to keep one of these around just for some random testing purposes. We probably won't need it, but just in case. Yeah, and then let's now give this a spin. So now we want to say git zig build run. Okay. Was not expecting this. Evaluation exceeded 100 backwards branches. Okay, this is because the stuff we're doing at comp time is taking more than 100 of some unit. So this, we can adjust this. Let's go back to the butterfly app, since we had to do this as well in that, and I forget the exact command. I don't know, we can look it up in documentation. So it's called set eval branch quota. Yeah, and then we just insert the number. So why don't we go then back to the level parser and add that in here. Is this going to be enough? Let's move this to say like 10,000. We'll see if this compiles now. Okay, it did. And great, our levels seem to be in here. So let's actually test these out. Let's create a different level. So now we can go back to our levels, and let's say we have level 3, and okay, let's make this one level 3. And then let's say we copy this one, but add in some more zeros in the place. Maybe that's a 0, that's a 0, it's a 0. Let's make like the final row all zeros as well. Okay. Oh yeah. We do need to adjust this thing. Yep, great. There's our 3 levels. One with this 0 row missing. Okay, so our kind of comp time parser is complete then. Great. Yeah, I'm happy that they didn't. I mean, that took less than an hour, which I like. This demonstrates that Zig is quite already a competent language. Okay, yeah, so it was less than an hour after we kind of copied this stuff, but the more times I look into this, the more I'll remember it. So git status. Besides, we wrote this, some time ago. We figured out how to do this from scratch anyway. So now we can do git. We kind of want to add everything, I think. Like what saying has changed? Okay, we did those things. We added in a different level. We added in those parsers. Great. Yeah, so I can say like started using the parser in main.zig, added another test level. Okay, great. Okay, so that's one less to do done. So this can now go. Okay. So now onto something that's probably a bit harder. What shall we do next? This is like the hardest thing. We will do this last, if at all. And I think it would be fun to do. Maybe it is time to do button kind of stuff. So I think for me, it just seems the most important feature that's next. Also, we need to do documentation at some time. So maybe I'll add, let's add this in maybe, once we've got dragging working, we'll do like, a readme file. Yeah, I do want to start getting this to the stage where tiles can actually be dragged onto this and we can get a game going. I suppose the question is, do we try and do that functionality first, or do we instead do buttons? Like, we'll do them both together since they're both going to be quite related. I'm not sure what to do first. Will it actually matter which one we do first? Because if not, there's no point thinking about it for a bit. I feel like it will. Yeah, I'm thinking of kind of doing the buttons first. So if instead of just like clicking to get between these puzzles, we do have some button, we'll need to write some code that just detects when a button has been clicked, which will just be when has the mouse been clicked and is the position of the mouse in one of these buttons. And then we may as well also do some kind of hover logic for the button, so that when the mouse is hovered over them, the button changes color in some way. And then once we have those features in, I feel like the tile dragging stuff should be somewhat straightforward. Let's see. We would just need to, for the tile dragging to work, we would just need to detect when either, okay, so if we're doing tile dragging, a tile can be dragged in either two places. One, the tile is just like selected from this like infinite pool of tiles at the bottom, and detecting whether the mouse is clicked on any of these is easy. We should actually clean up the code a bit down here slightly, in a similar way to last time where we had this struct that had some of the grid geometry, and in particular we calculated all of these tile positions and put them into a super easy grid to access. It would be good just to do a similar thing down here. Okay, but in either case, either tiles get dragged from here and then we just iterate through the analogous version of this, but for these options, or a tile gets dragged from up here, so then likewise we iterate through this exact list and then check if the tile that has been clicked is currently occupied with a tile that could be blank, that could be movable. But yeah, in either case, if we just write these buttons as being some squares to begin with, stuff will immediately follow over. And likewise, if we do the button logic with hovers, we could likewise do like maybe even like a change in color, or like a border color change when a mouse is hovered over one of these tiles. Okay, let's get some button stuff working then. It would be easy to begin by just making all of the buttons just be rectangles, but I kind of want to do something better. It would be nice to have some buttons that had like arrows or something on them. Likewise, something for the main menu, which we don't need to do yet. If we're doing buttons that are not just a rectangle, it might be good to have some struct that just like captures their geometry in some way. But perhaps this is an unnecessary level of detail. Maybe we actually just make all of the buttons rectangles, and then we just design them in such a way that like the detection is always going to be some rectangle, and then we just like draw a symbol on them that uses this geometry of a rectangle. I think this would be the easiest way to go, so we'll just do this. All buttons in this game will be rectangles. More complicated geometries will be for future games. Okay. So yeah, let's denote which current one we're working on. And actually we are just going to just do and just do rex. Okay. So let's make a struct that would just be a button. Don't need this to be a global. Yeah, let's put this struct above, around here maybe. Maybe below here. So button will be a struct that has a rectangle. Do we even have a struct for a rectangle? A type for a rectangle. I feel like we should. But maybe we don't. Have we actually got this far through the programming where we haven't even created a struct for rectangles yet? I think this might actually be the case. I think we've just been drawing all of these rectangles as like a position and width and height. Okay, this is interesting. Yeah, we don't actually need we don't need a struct for rectangles. All we want is the position of the button, which, like everything else we've done, will just be a vec2. And we want the width of the button, which, like everything else, would just be an f32. And the height. Yeah, and then we have the position. And then, yeah, yeah, this is all we need. Don't need anything more complicated. And then we want, say, like we want some colors. Well, actually, maybe we don't necessarily want to store the colors in here. I disagree. I think we want to. So we want a couple of colors. We want maybe like 2 colors. One for like a background, one for some symbol on the front. And then we also want an additional color, or maybe even 2 additional colors for these to slightly change when the mouse hovers over it. So why don't we literally just call these like color 1 using the color type we have, which is what? Maybe we even don't yet have a native color type, and we've just been converting all of these to the Raylib versions. This would probably be something good to change, yeah. Okay, let's add in a type for this. It's called the color, which is a fixed array of 4 U8s. So we've got this, and then we want the hover colors. So why don't we call this like, I want to have some names for these, like non-hovered and then hovered versions. So maybe just like default color 1 and default what about like default color 1, color 1 default, color 2 default, and then the hover version of color 1, and then the hover version of color 2. Okay, and then I think this is all we need. When we actually do the rendering of these things, then we can go fancy and say, yeah, like draw some like triangle here, draw this rectangle here, blah, blah, blah. But all of that stuff, at the end of the day, all we need to know is how to draw all of this button minutia relative to the width of the background rectangle, the height of the background rectangle, the position, and using this information. Okay. So now I kind of want to rewrite the colors a bit to just use the simple version of colors and not Raylib's like you have to like specify this is like the R type and like the B type instead of just like this is 0, 1, 2, 3, and 4. That's all it is. So I feel like this is going to be a bit painful to kind of redo this and all the other places where they're called in the code. But then on the positive side, more code will just be in Zigland before getting shifted over to the C types. So yeah, let's like, yeah, let's replace all of these. So we can do macros again. We can say delete these and replace it with a color. Okay. I really love Emacs macros now. I can't imagine programming without them now. Okay, so now all of these are colors. This one too, got to switch. But this is going to cause so many compile errors. let's just get with it. Zig build run. All of these failing. So yeah, I think the only way to go through it is just kind of do it like this. Do it line by line. This was in 205, though, wasn't it? Okay. So yeah, this raylib function is intending that we're going to convert this over. So we'll just do raylib color. We're just going to start wrapping all of these colors when we actually call them in raylib functions with this raylib color thing. And let's now change the definition of this thing to now just say this is going to accept a color, and then output this raylib color. And in particular, we're now saying, yeah, this raylib value is now just the color 0. This is the color 1. This is the color 2. And this is the color 4. And what's this like pixel to RL? I'm not calling this anywhere, so probably we can delete this. Okay, yeah, I think this is going to be a bit painful to convert, but it's better we do this now and have everything systematic than just keeping like 2 different conventions going and then 10 hours later going, what are we doing? We have even more code to like fix up. Okay. 90, what's this one? Index 4 outside of array length. That is meant to be a 3. What's this one? Yeah, RL image.draw pixel 2 to 8. Okay. Let's clean this part up. So this should be our new type, and yeah, so this should just be raylib color this. 312. Another error. Raylib color this. Ooh, yeah, yeah, this is fine. This is what we want to do. What's this one? 353. Oh, okay. If we're actually doing a draw centered rect, this is our own function, so we better not be wrapping colors here. We better just do this within the function itself. So let's see, function draw centered rect. We want this to be our colors, not the raylib, and then here is where we convert it. Right, this stuff's okay. This stuff seems to be compiling, so I think we will get rid of this later. 427. This is not our function, but it's basically within our function. And don't know why Raylib needs a color there, but okay. Okay, great, and it's compiled, and the colors are working, which we entirely expected. Okay, that was way less painful than I thought it would be. Get rid of this thing. Okay, and now back to the color stuff. Let's save what we've done. Added in custom started using type color equals for U8 instead of using Raylib colors everywhere. Push that to the cloud, and then, okay, back to button stuff. We'll make this full screen. So, question, would it be useful to have this stuff in a separate file that just contains button logic stuff? Because it's not as if this is the first and last game we're making that's going to contain buttons. And having something that we could just copy from another project, copying, say, a file we make here into a future project could be quite useful. Like, we're certainly going to be doing that with the QOI parser, the QOI decoder we wrote. I'm feeling it actually would be nice just to have all of this code in some self-contained way. Okay, what could be a potential problem with, or some annoying factor of having this in a separate file as opposed to just in this one? If it's in a separate file, we need to, obviously we need to import it, but that's kind of trivial. We would have to write the button functions there so as to accept stuff like a mouse position and other stuff. But I think that's fine. Yeah, okay, I'm not immediately seeing any reasons why we shouldn't be doing this in some other, why this shouldn't be in some other file. So now let's create something called buttons.zig then. And let's kind of just start by copying this. And then over here, and let's import it too. We want to say we're going to be calling buttons a lot, so why don't we just call it button? Buttons, let's see. Okay, and then now for this struct stuff, we can now just say this constant struct is going to equal the thing called button in our imported file. This should still compile. No, good thing we did this. Vec2 is, we'll type this. And yeah, likewise, I feel like color should be around here. Let's move this up to here, go back to color, pixel. What am I doing? Okay, working. Yeah, so now let's write the functions that we need. So currently in this app, we're just clicking goes between all of these different puzzle states, levels, etc. What do we want to do? We want to now control the level transition with some button. So maybe we have a button like, where should it be? Could even be at the top, possibly, to just go to the left and the right. Yeah, that feels, that maybe feels like we can adjust all of these things later. These are just temporary positions, but we'll put them up the top here to begin with. Okay, and then we might want to have separate, so there's a couple of things we need to do. We need to first have some code to render this. We then need to have code to detect when these things are clicked, and that's kind of all we need. So let's just start with the rendering part, and then once that's on the screen, we can do the logic with it. Okay, so why don't we define, what should we define first? Yeah, why don't we start doing like the rendering for a, like, for like a left arrow button, say. Render left arrow. When we render this, we're going to have to do some handles to stuff. Okay. Ooh, yeah, this is becoming slightly complicated, but it still should be fine. It's still manageable. Manageable complexity. So yeah, so currently when we're drawing all of these things here, literally in the main file, in the main loop, in this render loop, we're just saying draw all of these rectangles, draw some textures. That's kind of all it is. If we're calling arrow function construction over here, provided we call it within the main loop, stuff should still be fine. Yeah, so in particular, provided we just use the standard Raylib geometry functions we use in stuff like draw centered rect, which is literally just drawing a rectangle using this thing, we should be fine. Okay. So let's do the background of the rectangle first. In order to even know the color to use for the background, we should know if the mouse is hovering or not. So why not store this as a Boolean? So hovering, and then we'll kind of set this. We'll set this during the mouse processing part, and then yeah, literally it's just going to be draw. Ooh, I want to see it. We're drawing this centered rect, but this draw centered rect is now the like function in main. Maybe we should start moving the rendering stuff to a different file. Like, it's not that. It's simple enough that we could just replicate it in here. I don't like the idea of that. But it kind of is pretty simple. Like in Odin, this issue doesn't happen at all. You don't need to think about some like control graph of like what files rely on another. Everything in the same folder works. Given that with this button geometry stuff, we'll need to know the positions of a lot of stuff anyway. I mean, especially for drawing triangles and stuff. I'm kind of tempted just to be calling this, and for there to be no reason to actually call this one. Like this won't be useful in every single case, but at least for this arrow function, I think it will. Because what I'm going to do, we're just going to have to draw a bunch of rectangles as well as the triangle. What is this raylib triangle function? How does this work? I don't remember using this on any of the stuff we've developed so far. How do we do like draw? We want to draw a triangle 2D. Triangle 2D. That doesn't exist. Okay. What about just like a triangle? Okay, looks like this kind of stuff here. Draw a color fill triangle in counterclockwise order. Oh, this is no. We don't want to have to be like doing all of this using these like raylib vectors and everything. Okay, why don't we instead create another file called like shapes.zig, which literally the only job of the shapes.zig is to like do the raylib drawing version of this kind of stuff. Like this shapes is where we'd have like draw centered rectangle, draw triangle, probably even like draw texture actually. Okay, yeah, I'm liking this idea. Okay, so we'll just do like shapes is fine just for rectangles and triangles, but I also want to move this texture function in here as well. What if I call it like render basics? Well, I'll just call it shapes, and then I'm writing this code. It's obvious to me. Hopefully in the future I'll remember this. Okay, so let's move all of this stuff in it to here. And yeah, we're gonna have to import this as well, but that's fine. Where should we import it? QI parser this. Okay, and then we have a lot of draw rectangle calls, and do I want to put shapes in front of all of these? Let's see. Draw centered. Right. 1, 2, 3, 4, 5, 6, 7, 8. Actually, it's not that many. 8 calls is totally fine. Okay. Yeah, let's select everything and replace draw centered rect with shapes dot draw centered rect. Yep. Those are fine. And then in here we need to define what, like all of this stuff. And then maybe we don't need, okay, we'll leave pixel in there just in case. And then here we're going to have to again denote what the raylib stuff is. Come on, copy, paste. And then hopefully this is kind of the only thing that we need in here. Yeah. Let's just comment this out and check that stuff is still compiling. No build, please. Okay. What are these errors? In shapes, use of undeclared identifier RLC. Yeah, RLC is something that we should move to shapes, since we're converting the colors. FN RLC. Or should we? Yeah, it's fine. We can actually just define this function in multiple places. It's going to be inlined by the compiler anyway. Okay, so now we're doing 3 to 9. Draw centered rect is not marked pub. Okay, it is now. Oh, it is now. Okay, app's still working. Great. So now we're gonna have to want to do a triangle at some stage. So I'm going to call this like draw triangle, and we'll figure out the details later. Okay, but back to our buttons. Now we actually want to import the shapes that we just defined. Import shapes.c, and then we can start using that here. So now we want to draw a centered rect literally at the position, or we're going to have to choose the color. So you can say background color is going to equal either this one if there's no hovering occurring, or this one if hovering has occurred. And so we can say this is if, okay, side tangent, given that like Zig has like one level of object oriented, this stuff could possibly be within, no, okay, the stuff could possibly be within this. We'll keep it separate for the moment. But there may be some, just because this is a very specific function, there may actually be a reason to, like, when we do like the detected if it's clicked, that probably would actually belong in this. But we'll just keep everything separate for the moment. So yeah, so the background color, if we also need to know a button. Yeah, in order to render the left arrow, what do we need? We want to just know the button. That's kind of it. Well, do we even need to know the position of this? I feel like the position is something we should be... Let's work with this at the moment. We can always delete stuff later if needed. Okay, so if it's hovering, the background color we want to be color 1, the hover. Otherwise, make it the color 1 def, the default. So now draw this centered rectangle with the background color, and in terms of the width and height of this rectangle, we just want the width of this and the height. Yeah, the width and the height. And then, okay, now we want to do this like arrow geometry. So now, for the moment, when we get stuff on screen, let's make this button really crude. It would just be a smaller rectangle inside the rectangle. So this is massively temp. We'll continue this shortly, but let's just, once we do this, we'll start getting it rendered in the game, and then we'll refine what the button looks like. So likewise, let's draw a smaller rectangle, which is now half of the width, half of the height, and then if I call this a like detail color, we can do a similar thing here. If it's hovering, use the color 2, otherwise use the color 1. We have the detail color. Okay. This should hopefully work. And then we want to now call this in main. So in the render puzzle part, what's the stage at which to draw this button? If we render this in such a way that we're just working from top to bottom, we may as well have the buttons at the very top. So now we want to say simply button dot draw I already forgot the name. We want to do render left arrow. And then we need to actually make a left button. So why don't we call this left arrow button? And then, okay, this left button should probably be a global. So let's see. Under the game, why don't we just, where should we put this? Screen geometry, let's put it here. Buttons. So we'll have a variable called left arrow button, which is going to be of type button. And likewise, not of type, and these are currently undefined. And then we want a right arrow button as well. Okay, and then we're going to have to set the geometry of these in the calculate geometry part. So this is so vague. Of course, this is what this function is doing. In this part here, what are we doing? We're doing like grid geometry calculations. How do we spell it? Calculations. But before that, let's do the button calculation. Oh, come on. Calculations. The grid calculations. Okay. Okay, so now we need to set the position of the left and right arrow buttons. So we have this left arrow button. Okay, there's going to be a lot of things to fill. We need to set most of these. Well, some of them. Okay, so why don't we say then, left arrow button dot, some of these, let's see, the width is, like a lot of these things are dynamic. What's dynamic? The width is dynamic, the height is dynamic. This stuff is not. And the position, so all of these are dynamic. All of these are dynamic. This is set in the mouse hovering procedure. These are the stuff we need to set now. But really, actually, this stuff here should be set at the very beginning. Why don't we move this to the, let's set this stuff in the globals. We'll come back to this. Did I not? Globals. Okay. Okay, so let's set some of these. So really we want to say this is equal to, instead of being undefined, let's set the hovering to be false, to be fails initially. The width, this is undefined. The height is undefined. The position is undefined. Will I be allowed to do that? This line here might give an error. We'll see. Okay, but in terms of the default colors, this is we really should set. So what does the app look like at the moment? It currently looks like this. So let's make the background button color this light gray, and then the foreground button color will just be this debug color. Let's go back to main, jump back to globals, and then what are the where's our colors? Up here. So let's just use light light gray for perhaps actually instead of setting this explicitly here, we should make another global color that is something we can set. Yeah, I like this idea more. Okay, so let's have a constant arrow button background color. We'll make this light gray. And then the arrow button detail color, we'll make this kind of ghastly debug color. Nah, we can do better than making this a debug color. Let's actually choose this now. Why don't we set this to be all of these colors are like crap and not the final ones. Let's make it yellow. Okay. Then over here we can say this thing is now going to be the arrow button background color. And then the next argument is the like hover version. We'll make the hover versions debug, but again we should also be setting these. We should have globals for these, I think. Yeah, arrow button. This is a lot. Should I really call it this? Yeah, why not? Why not? At least it's immediately obvious from the name of this variable what it's actually doing. Arrow button detail default color. Right, arrow button background hover color. Make this debug. And then likewise for the detail version, also make this debug. Okay. So now up here we want this to be the default one. Like we literally just like copy this in. That's all we're doing. Except that Emacs, I said do that, good. And then yeah, remove this. Okay, this is silly. There was no need to use a macro here. That was really silly. Yeah, that's kind of all we need. And then likewise, we just want, so this being a variable needs to equal this. We just want the right arrow button to have the same stuff. So we can just make this equal, copy over all of these values. Let's check the ordering here is right again. So we're saying the first two colors are the non-hovered ones, and then these ones are the hovers. Yeah. Okay. Okay, that was a trip, but now we can actually get back to using these to render this thing. So if we go back to main now we've defined these things. When we actually render them in here, well, yeah, we need to set the geometry of these things. Okay, now we set these things, we just need to set these values. So now we want to say the width of this button will be what, like 5% of the screen width. And hopefully, I guess these should be globals. Yeah, they are. Likewise, the height of this thing is just going to be, say, like 5% of the screen height. And then the position is literally going to be, well, this is something we need to define. So we want this to be what, the vec2 that is, and it's implicitly a vec2. A vec2 that is, well, where do we want this? Let's move this like 1/10 of the way from the height and in the center. So 0.5 times the screen width, and then 0.1 times the screen height. But we kind of want this to be offset in some way. So if we want this to be offset, let's make this 0.4 instead. Okay, and then let's do almost the exact same thing with this version, except the position is now slightly more over. And we want this to be the right versions. And now we just need to determine whether these things are hovering. But we don't yet need to do that. Since this, yeah, let's just get stuff, let's get these on the screen. Okay, and there are going to be some compile errors. No, I don't want emojis windows. Okay. Line 17 in buttons. What's wrong? Yeah. It is a void. 27. Yeah, this is a function, so it doesn't need a semicolon. 21. Use of undeclared identifier hovering. Right, since this is button.hovering. Use of this is unnecessary. Let's just label this thing B, and then if b.hovering, b dot background color, no, just background color, and let's see, b dot width, b dot height, b dot width, height, yep, okay, oh, b dot plus. Use of undeclared identifier, yes, because we are now using the shapes library for this. Shapes file, it's not a shapes library. Yeah. Button is not marked public. Okay. Button does not support array initialization syntax. No, you've got to be kidding me. That's annoying. That's annoying. Okay, let's deal with this. Okay, so now we're saying, like, this problem doesn't exist in the Odin programming language. Why does this exist here? Anyway, maybe some legacy of C. Alright, so what... Maybe we simply just say what these fields are. I think that's all we need to do in order to do this. Yeah. So, okay, so if we just say, and actually maybe this is better since it becomes more readable. Hovering is this, the width is this, the height is this, the position is this, the first color, what am I doing? The first color is that, color 2, the default's this, color 1 hov equals this. That's it too. Okay, as I suspected, this was going to give us grievance, but that is okay. That should be fine. Good. What's failing now? In main 162, unable to resolve comp time value. Why not? Like everything in here is a constant, so this is just a constant, but we're going to be changing it. Why is this failing? Container level variable initializers must be comp time known. What? Like what on earth could be going on? I just want this to be something that's just in the data section of the executable, and that we just set out the memory layout for this, set some default values, and then simply make like a duplicate of this, but call it right arrow button. Why is this failing? I don't get it. It would be so crude just to copy and paste this, but I could do that. I don't like the idea of this. Okay, so what are some options? Because we kind of, I want these, I kind of want these to be globals. Now, the problem is I don't understand this error. That's the problem. I don't understand why the compiler is having a whinge. What on earth is happening? I don't know what it means by container level variable initializer. I know what this means. I know what this means. I think I know what that means. But like, what's container level mean? Yeah, this I know. This I don't know. Container level. Let's just. Let's use the LRM. Let's see what this says. Okay, this not useful. How can I fix the Z error? This. But again, like, why is this not known at compile time? Like, it's that part I don't understand. Like, it's all of these are extremely concrete values, as are these. Like, if we go to the colors that we just defined, all of these things are comp time known. Like, what's the problem? It seems totally ridiculous to have to like wrap this in a comp time scope, but maybe that's actually what I need. Like, this feels so dumb. Like, do I really need to say this? This feels really silly. Yeah, exactly. This is already in the comp time scope. So how do you not know that? Okay, I think I understand the problem now. Since this itself is not a comp time value, this equal sign is expecting whatever is on this side to be, even if everything inside of it is not. Okay, so why don't we actually just fix that? Why don't we say constant arrow button defaults, all of this stuff, and then we simply say the left arrow button is equal to this, and this is equal to the right. Okay. Dependency loop detected. Yes, because we don't actually want those to be here. We want this to be the arrow button defaults. Okay. Aha, and the button is drawing. Great. And yeah, the height is changing, which is not great because the width, like one of these should be relative to the other. Yeah, let's change this. Okay, so now when we go back to the calculate geometry function. Once we've set the width, let's make the height like 7.5 times the width. This is we're going to be setting the width the same for both of these, so why don't we just make this a constant? Button width is equal to this thing, and now the button height is going to equal 0.75 times the button width. Now we can just set all of these to be the expected things. And then in terms of the positions, yeah, why aren't we drawing this other one if we've calculated it here? I guess it's because we're not doing it. So button.draw when we're doing the render puzzle, we want to say, yeah, we now want to also render the right arrow button. Okay. Let's check this. Let's check this is okay. Yep. And then the ratio of these randomly changes with raylib changing for a single frame, but is otherwise constant. Okay. Good. Let's now flesh out the geometry of these a bit more. These look too tiny for my liking. So yeah, if we go back to calculate, let's change the width and height of these. Why don't we actually make these the size of the tile thickness? Like, is that needed? Actually, no, they shouldn't be as prominent as that. Let's make it like, what should we make these? Oh, and then to be like 50% larger. So let's just make them 0.75, and maybe the height of them can remain a bit smaller. Okay, what do these look like? These are now way too wide. Oh no, this is no. I'm not liking this. The size of these are like massively changing. The size of these should really be constant with respect to the grid height. So we'll just do that. So we just want to know the tile length. So we'll make this button length now, the grid geometry, and then the tile length. No. I guess we'll have to move the button calculations down. Okay. So now the button width will be 0.75 times the tile width times the tile length. Then we get that, and then we get these other things. Okay. Oh. 275. Yeah, this stuff should move down as well. Okay. Okay, their position is a bit whack, but it's temporary at the moment. Maybe it would be nice just to align, to like center align these with respect to the first column and then this last column. I mean, why not do that now? Let's just do that now. So, so given that we know the position of each of these tiles, we can like we can precisely position these buttons. So, so in particular, what should we do? Why don't we vertically center these as exactly halfway between the top of this grid and like halfway between the bar and the top of the screen. Or maybe, yeah, we'll do that. So okay, this position is what we need to think about. So we want to say the first X position here would be the same as the X position of this thing here. So we just want to say grid geometry dot grid tile position. Okay. So the left X pos is going to equal this grid geometry, the tile positions, the grid tile positions. We can just use the top left corner calculation we did. TL, yeah, okay, no need to do this. TL tile pos dot x or 0. That's just it. And then the height we want to position halfway. So now we want to just say 0.5 times 0.5 times the really 0.5 times the center of the grid plus 2 width. We may as well just use this TL tile position. Take the height of this and before we halve it, add to it the bar thickness and add to it the half of the tile width. Let's add that in here. So yeah, start in the middle here, go up 1, then go off the bar thickness, and then we're at the very top border, and then just scale the entire thing by 1/2. Okay. And then once we've done that, for this version here, we now want the X to be this is, now we can actually say, these lines are not that long to do. Grid geometry, grid tile, position, it's, that's fine. Grid tile positions. Oh, I know this is like, stuff is like being messy here. Like this, when I look at this line, I'm just like, what's going on? We need to structure this slightly differently. Let's just say, yeah, the left posx, we need this to be consistent in some way. We just want this to be the very first tile here, plus all of this stuff. Oh no, that's all it is. That's all it is. And likewise, the right position of this button is just going to be this, but the fourth row. And then for the left position Y, we want this to be, this is going to be the same for both the left and the right buttons, but we want this to be the grid geometry of this thing again, but now once we've added in all of this stuff. We've boosted the tile width by 1/2, added in the bar thickness, and then multiplied the entire thing by 0.5. So okay, 0.5 times. Yep. Calculate the upper limit. This, half the tile width, add the bar thickness, and then half that. And then likewise, the right position of Y is just going to be the same. Okay, so now we can clear this and make it easier to read. This is now just the left posx and the left position Y. Likewise, this is now just the right posx and the right pos Y. Okay. Let's see how, let's see what this is now. Error. 299. What? Unidentifier tile width. Oh, it's tile length. Oh, okay. Mixed scalar and vector operands. Oops. This kind of feels serious. What are we doing? Oh yeah, this is, oops. This is just the position of the first tile. We need to actually select the X position from that. So, see, this is why it was good moving these on separate lines. It's just very easy to know what to immediately change. And that, and then for this one here, we're now just picking up the Y coordinate. Okay. Okay, at least this is aligned in the center, but where has the other button gone? Why has this disappeared? Because the right position is not meant to be the left posx. That's why. Wait, what? This should fix it. No, it's not. What? Oh, okay. That's why. The right pos y is the same as the left pos y, not the left pos x. Okay, great. There's our two buttons, and they are aligned with the columns like we wanted. But this isn't halfway between the height and the top of the screen. And I think that's because these pluses should actually be a minus. Yeah, this one here. Because we're subtracting from the current height these things. Great, now they're there. That's where I wanted them to be. Cool, now let's jump back. Like, we went so many layers down in terms of like just doing this button stuff. But we're now slowly returning to the surface. We now actually want to write the detail into what these things look like. So okay, so now we want to do, first of all, I want these to be slightly bigger. So let's change this. The height looks a bit too small. Actually, the width also looks a bit too small. So why don't we make these like 9 times the tile length, and the height will be like 7.5. Firstly, and then yeah, let's kind of figure out how to draw some arrow. So this is where we'll need to implement some triangle function. Oh, we're getting lost in the weeds again. Okay, let's continue to have this temp stuff in here. Yeah, this looks like a better sized button. We're gonna have to draw a triangle someday. Let's just get this going. Okay, so now we're doing this draw a triangle function, by which I mean procedure, since functions are exact mathematical objects. Procedures are the things in computer science that change. Yeah, so to draw a triangle, we want a position and probably just the coordinates of, position is vague. Like we kind of want, do we just want to pass in the coordinates of this triangle? I think so. Yeah, unless it's like an equilateral triangle or something exact, and even then, unless it comes with an orientation, yeah, not entirely clear what to do. Okay, so we'll just say point 1 is a vec2, point 2 is a vec2, and then point 3 is a vec2. And then we want to do what? We want to call the necessary valid function to do this. So, and we have to, it says like vertex in counterclockwise order. This is annoying. We'll have to figure out if the vertices that, like, in 0 worlds am I like figuring out whether these are in the correct order before I call this function. We're going to just do this within the function body. But we need to do this, and then we kind of just draw it. Okay. So let's like copy this. So the very final thing we want to do is raylib.draw a triangle. We have to like convert these vectors. This is annoying. What's the specific raylib vector format again? Raylib.vector to this thing. It's just so dumb. We have to do this or whatever. So say like dom p1 is like raylib, where like the x here is just p1 dot 0 p1 dot 1. Change all of these. Okay, and then once we have these, we simply call this draw triangle with these dumb raylib formats. And then the color, which we have to call raylib conversion color on. Okay, I think this should be it. We should also pass in the color. Okay. So now we've done that, we can actually draw a triangle in our buttons. So we need to figure out the coordinates of the triangles that we want to draw. So how do we do this? So yeah, we first draw this background, and then we want to draw arrowhead triangle. So that we need the points of this. So the first point, we want this to be a vec2, and how is this going to work? Why don't we make the first point like the halfway point on the left side. We can adjust it later, but this is, I think, a fine place to start. So this will be, what will this be? This will be the position dot we are going to be using the position a lot, so I just want to not have to write b in front of it every time. So yeah, so we're taking the, no, this is not good. This is unnecessary, it's actually fine. v.pause, so it's taking the, no. We want, we want the center of this button, and then we're subtracting from it half of the width, and then the height is going to be exactly the center of this button. Where's the second point going to go? Let's make this, to start with, like a halfway point again. So now let's say this is now, the x coordinate is exactly this one. And then the height is going to be the current height minus, oh no, what's the, okay, it's good. Good, I have like something I need to go to at 4, and it's still several hours away. So we can get this stuff done. Yeah, the height is now this minus some of the height. Yeah, and then finally this third point is going to be this position. It's kind of going to be, it's going to be the same, except this is going to be flipped around from a minus to a plus. Okay, and then now we want to draw this triangle. So now we say shapes.draw triangle, P1, P2, P3, and then the color, which we want to be the detail color. Okay, now we can get rid of that. Let's see if this compiles, and if it does, what it looks like. It doesn't compile. 16 in shapes. Expected return type expression. Yeah, it's a void. Expected type expression found that. Yeah. Okay. No yellow triangle is being drawn, presumably because the orientation is wrong. Which is something we need to fix in this. But just to check that that's the issue and not some other general rendering issue, let's flip those coordinates around. Hurrah! We now have our triangles appearing. Okay, so let's now move these back to the sensible option and deal with this thing. So now we can say note bloody raylib needs the points when drawing a triangle to be in a direction. What's the direction? And counterclockwise in a counterclockwise direction. So account for this. Okay, so we need to first detect the direction that these things are going in and change them if they're not going in the right direction. So so what's this? What's the way to do this? I feel like I've done this before, and I'm blanking on the mathematics. It's also a bit cold. Okay. Okay, so how does this work? We want to say you know what? There's an easier option than figuring out the direction. It's literally to draw each triangle twice. Honestly, like, since raylib is just a temporary fixture until we learn how to do Vulkan stuff, part of me doesn't care about duplicating it. So let's just do that. So draw each triangle with both directions. Okay. Yeah, I don't care. I don't care for this problem. Okay. So now when we draw it, no matter what direction we pass it in, one of them is going to work. Okay. Moving on. Let's now add in the tail of this arrow. So, and then we'll need to flip things around to do the render right arrow procedure as well. Draw arrow body. And so why don't we draw a rectangle from a fourth of the starting we could just say draw the centered hang on. Now that the triangle is working, let's adjust the geometry. Should we adjust the geometry now? I kind of want to adjust it a bit. Okay, instead of the let's move the arrow. Let's squish the arrowhead more to the left. So in terms of this position, instead of having it just equal to this, let's move that there, and then yeah, maybe that would be enough. Let's see. Yeah, I think this is okay. And now when we're drawing the arrow body, all you need to do is draw a rectangle. In particular, draw a centered rectangle at if we say 0.75, that would be the easiest way to do it, but maybe maybe we make this, what's the position? Let's make this 7 over the width, and then since this is centered, we just want this to be the honest position of. What am I doing with that? That calculation makes no sense. Let's just offset it from the actual position. So take the center of this rectangle and then push it slightly to the right. So maybe you push it by 2 times the width. And then in terms of the actual width of this arrowhead that we want to draw, maybe make this 6 times the width, and then the height could be a third-ish. Okay. And then yeah, let's move that here. Okay, let's see what this looks like. So, wait. Expected for arguments, find 3. Oh yeah, we didn't say what color this should be. And we want this to be the detail color. Oh, another error. Mixed scalar and vector operands. Wow. 24. Wow. It's the. No, I forgot. Yeah, in Zig, like, there is an automatic like overloading of this stuff for vectors. Wait, really? No. I think surely Zig knows how to do this. It's that these are like different in some way. So yeah, this one here is a vec2. Why does it think this is okay? Because I didn't tell it. This is a vec2. That is why. Okay, great. We have arrows here. This is fine for me for the moment. Almost. I want to increase the width, the height a bit. Let's change this from 0.3 to maybe 0.5 actually. And then we'll then copy paste this for the right arrow. No, that's way too big. Let's try 4. Yeah, that looks good. I'm happy with that. Okay, copy. Okay, there's an option to do something maybe sensible for the copy paste where we kind of say like flip everything over, like do a mirror image. It's fine. Let's simplify this a bit. My earlier comments regarding all of these buttons just being rectangles, I kind of want to change it. We'll leave it like at this state and move on. But it would be cool, like when we do the hovering stuff, for the hovering only to actually choose this if the mouse actually is over part of the geometry here, not part of this larger rectangle. And also now seeing this, I don't like this rectangle design. I kind of want to get rid of this background and just render the triangle, just render the arrows. We could maybe make this look better by adding a border to both of these, which we could do by simply drawing the geometry, but in a slightly smaller way. Let's adjust this one. Like, what is? I think we should be moving on. This is not the time to like worry about the look of these things in a lot of detail. Let's actually get the game working. Okay, so let's copy paste this. And then I'm kind of not liking having all of this repeat code. Maybe we actually have a switch. Like when we render this left arrow, we just determine if it's like a direction it's in. Yeah. Let's just make it a, let's just call like the direction pointing left. And it will be a bool. And if it's pointing left, then if it's true, that's what gets rendered. Otherwise, we will flip it. So we need to flip it when it comes to a couple of these calculations. So this is the same, but for this one here. And this, we want this to be, say, like 0.4 or 0.6. So why don't we now say this is, we're going to have to change this line a bit. Actually, this is fine. I don't know what I'm talking about. This is it's the direction of this. It's really this sign here. We want this to be a plus if it's a left-facing arrow, or a minus if it's a right-facing arrow. So like normally in Odin, I would just multiply this. I would just say convert this to an assigned integer and then multiply this by it. But Zig doesn't like scalar multiplying a vector. But that's fine. This just means we can just scale. We can just be adding plus or minus this argument. So then in here we want to say float from bool. We'll just call it left. What do I want? I want to call it like a left direction, but not as long as pointing left. We'll just call it left, whatever. Okay, and then hopefully that should at least compile. No, it's not liking this. Float from bool. How do we do this? Float from. Oh, I think I discovered this a while ago. Yeah, there's no like float from bool. You have to like. It's so annoying. You have to turn it into a. Okay. It's just the left facing is just going to be. Not just a bool now, just an integer with one byte, and now it's a float from it. And we kind of want this to be a signed integer though. That should be fine. We'll see if the compiler can handle this. No, it doesn't like it. We'll just make sure this is. This is annoying. It should be able. arrow is pointing left. It's a bool. And then we'll just call the direction is now going to be a float from a direction which is of type F32 is now a float from an int, and the int itself is I have to specify this anyway. And the int itself is an int from bool, right? Does this exist? Yeah. Okay. Yeah. Arrow is pointing left. And then down in here, we just want to multiply this direction. And it should be, this should work, if it compiles. If it doesn't, why does it expect one argument for float from int? Okay. In which case, we'll say as an F30. Let's just declare the type of this to be an F32, and maybe this means we don't now need to use the other thing. Why is this here? Let's move it over this side. Okay, that seemed to do it. Great. So now in main, we need to tell the direction of these arrows to go in. So this one is pointing left, but this one is not. And then we're going to have to go back to the buttons and change what's happening. Root structure file buttons has no member named render left arrow. Yeah, because it's render arrow now. Good, okay. And yeah, this is the position of this is slightly changed, which is what we want. But it's not going all the way over. Okay. So now what do we want to do? So for the arrow body, we're changing the direction that we're shifting the center of this in. And then, but no, I'm still confused why this isn't actually going all the way over to the other side. Like, has it just been that this has become converted into a 0? Like, there's an easy way to test this. If arrow is pointing left, do this, otherwise don't. Yeah, as I suspected, this is not behaving as I wanted it to. So this int from bool is, yeah, it's actually, it's sending it to a 0, which is not what we want. I should have read that. Okay. convert the direction to plus or minus to +1 or -1. So we want to do what? We've converted it to there's a really easy way of doing this that doesn't involve any conversion whatsoever. The direction equals, which is an F32, equals 1 if, or rather, if the arrow is pointing left, it's equal to 1. Otherwise, it's equal to -1. There we go. Problem solved. No need for any complicated type conversions. Okay, it's going the direction we want now. So now let's say we need to adjust the directions of these things. And also, why is the title of this stream called Late Night Raylib Experimentation? This is called game button making. Maybe just like buttons and like making buttons in Zig. Okay. Because it's certainly not late night. This is a different streaming time from usual. Okay. So now we've got that. Things must be changed. So and it's only the horizontal positions of things that will change. And so hopefully in a similar way that we subtracted things from centers to get these, we can simply add them to centers to get the corresponding parts. So it looks like we can do a similar direction thing with the X positions here. So if we just say subtract the direction times these values here, maybe that's all we need to do, hopefully. Yeah, kind of. Oh, now there's like this ugly. There's like a single row of pixels that is appearing on my screen for this part here that I don't like. We can just hopefully this is because the end of the rectangle is currently in line with this. If we slightly make the rectangle larger, I want this problem to go away. So let's adjust the width of the arrow body. Let's make this width like 7. Let's make it 8. And then therefore the halfway point is the rectangle now has like a radius, a horizontal radius of 0.4. So then if we still want it to be aligned on this side, we want to be drawing it at 0.4. So which means the offset should be -1, 0.1. Great. Now there's no weird single line of pixels appearing in the arrows. Yeah. Look, yeah, I think next time will be a continuation of this stuff, and I'm now actually getting the button click logic working. But we now have some buttons in here that are drawn, which scale like dynamically, which are aligned. I'm happy in terms of progress. Okay, let's save and push everything to GitHub then. Oops, so do this. Abner, I need terminal click so badly. This ridiculousness of using PowerShell where you like rechange the window and text goes off the screen, or you're retyping of the text. No, this is unacceptable, but Microsoft doesn't care enough to fix it. I'm waiting on terminal click. Like, terminal click will be the best birthday present, holiday present, whenever it comes out. Whenever I get onto the beta. Okay. So yeah, let's just see what we did again. So yeah, we added all of this. We made some default structs for these arrows. We did the button calculations. And yeah, we also did, come on. We made this one, and we made the button stuff. Yeah, we've done a lot. This idea that like some programmers today can only do like 10 lines of code a day is obscene. Like, come on. In like less than 3 hours, we've done like probably more than 100. Okay. If not more. So yeah, let's say, yeah, we started drawing arrow buttons in, moved some basic geometry render cores to shapes.zig. Yeah, that's fine. All right. Yeah. So yeah, I think then that's going to be it for me today. Yeah, tonight maybe I'll be able to do some more. Probably not. But yeah, I wanted to do something this morning. And yeah, not only did we write the parser, but we've got to start on the buttons. And so I think next time we'll start making these clickable and get these to control the direction of these levels. That will also enable us to, in like the main menu, to have some button here that's like handcrafted puzzles. And then we'll start to, we can start to implement the logic for dragging these tiles. And after that, a lot of the game will be working. So yeah, thanks everyone who came in and watched for minutes or hours. And yeah, hopefully I'll see some more people next time. Bye.